Welcome to Chapter 7, Day 3. We're going to learn the two multiplication properties today. So the first one is called power of the power. So when you have a power, and then that power is taken to another power, you multiply the exponent. When you have a power of a power, you multiply the exponent. When you have power of a product, so here we have a power, and it's on this product, x times y. That power goes on both of the pieces of the product inside. So it'd be x to the m, y to the m. So when you have a double power, a power of a power, you multiply the exponent. When you have a power on a product, you bring that power inside everywhere. So like number one, you have p to the negative 3, then to the second. So this is a power of a power, so you would multiply. Negative 3 times 2 is negative 6. We can't have negative exponents, so we make it p to the positive 6 on bottom, and have to put the 1 on top. So then all the other properties we learned still are in effect too. So here, number 2, that negative 4 would come inside to both pieces here. So we'd have 4 to the negative 4. X is to the negative 3, then to the negative 4. So when you have a double power, you multiply. So negative 3 times negative 4 is 12. So then my negative exponent is going to have to move. So we have x to the power of 12 over 4 to the power of 4. Then we would use our calculator to figure out what 4 to the power of 4 is. So 4 to the power of 4 is 256. So I would have x to the 12 over 256. All right, 3x to the 4th, all to the power of 2. That power of 2 would go to both of these. So we have 3 to the power of 2, x to the power of 4 times 2. Well, 3 squared is 9, 4 times 2 is 8. So we have 9x to the 8. Number 4, that negative 1 needs to go inside everywhere. So we have 3 to the negative 1. R to the negative 2 times negative 1 is positive 2. My negative exponent would have to move. So r squared stays over 3 to the positive 1, which we typically would not write that exponent of positive 1. All right, so now you can see you have 3 pieces to the product inside. So that exponent of 4 on the outside is going to have to go to 3 places. So we have 3 to the power of 4, y to the power of 4, x to the power of 4 times 4 would be 16. So then I use my calculator to figure out that 3 to the 4th is 81. And then these both have positive exponents, but they're in the wrong order. So typically we go alphabetically to be in proper form. To be 81, x to the 16th, y to the 4th. Number 6, the exponent of 3 comes inside everywhere. So we have 3 to the 3rd, a to the 3rd. 3 to the 3rd is 27, a to the 3rd, which is simplified. 7, I see a power of 0. First thing I'm going to do is get rid of that, right? Anything to the power of 0 is 1, which doesn't do anything. So now I have 2 places to bring the power of 3. So I have 2 to the power of 3. V to the power of negative 1 times 3 is negative 3. Well, 2 to the power of 3 is 8. V to the negative 3, I'd have to move to the bottom to become V to the positive 3. We have 8 over V to the 3rd. Number 8, we bring that exponent of 3 inside everywhere. So we'd have 3 to the 3rd, y to the 3rd, x to the 4 times 3 is 12. Well, 3 to the 3rd is 27. X to the 12th would go next, and then y to the 3rd. Look at the last 4. Ooh, I see some zeros. So the first thing I'm going to do is get rid of my zeros. But then I see I have A's and B's in there. I'm going to multiply those together using, when I multiply the bases, I add the exponents before I bring in the exponent of 2. Because if I bring this 2 in now, I've got 1, 2, 3, 4 places to bring it. If I multiply them first, I'm only going to have 2. So a4 times a squared, when I multiply like bases, I add the exponents. So 4 plus 2 is 6. B to the 3 times, b to the third times b to the negative 3. When you multiply like bases, you add the exponents. So 3 plus negative 3 is 0. Still to the power of 2. Oh, nice, because now b to the 0 is gone. So I only have one place to bring it in. So a to the 6 squared would be a to the 6 times 2, which is 12. A to the 12. Let's see, number 10, I've got power of 0 I'm going to get rid of. I can't multiply these together right now because I have to take care of this exponent first, right? Please excuse my dear Aunt Sally, exponents before multiplication. So that's going to go everywhere. So I have the 2u to the negative 4 times 2 to the 4th. U to the 2 times 4 is 8. V to the negative 2 times 4 is negative 8. I know this 2 has an exponent of 1, so when I multiply like bases, 2 to the 1st times 2 to the 4th is 2 to the 5th. U, I've got u's here and here, so negative 4 plus 8 is 4, and then I have the v to the negative 8. Well, I move my negative exponents. 2 to the 5th is 32, u to the 4th, over v to the positive 8. All right, 11, I got to take care of that outside exponent before I multiply. So nothing I can do to simplify the inside, so I'm bringing in that negative 1. So I have 2 to the negative 1. X to the negative 2 times negative 1 is 2. Y to the negative 3 times negative 1 is 3 times y x to the third. So my negative exponent's going to have to move. So he's going to be 2 on bottom. It's a positive 1. We typically don't write. X's that I'm multiplying, when you multiply like bases, you add the exponents. So x to the 2 plus 3 is 5. Y to the third times y, which would be y to the 1, would be y to the 3 plus 1 is 4. We have x to the 5th, y to the 4th, over 2. Number 12, we bring in that exponent of 2 first. So we have 2y x to the negative 4th times 2 to the power of 2. X to the power of 4 times 2 is 8. Y to the power of 4 times 2 is 8. So let's see, I'm multiplying like bases of 2. That was a 1. So 2 to the 1 plus 2 is 3. X's would go next. So negative 4 plus 8 is 4. Y to the invisible 1 plus 8 is 9. So then I would just figure out 2 to the third is 8. X to the 4th, y to the 9. So those are our 2 properties today. When you have a power of a power, when you have a double power, you multiply. And when you have a power on the inside, you bring it to all of the pieces of the product on the inside.